Okay, cool. So since we are supposed to get started already, I will start with another poll. So today's talk is about zero trust with legacy environments. My name is Melvrick. I'm from Singapore. So let's cover briefly of like what we generally work with first. So today's talk is zero trust in legacy environments, particularly for a lot of us that work in like big banks or fintechs or like e-commerce companies, like let's say your Lazada or Shopee, who have been around for quite a while. So yeah, a little bit about myself first. From Singapore. This is a view of our office, so we got a pretty good view of the city as well. And yeah, today's topics is split across 4 fronts. We'll talk a bit about like legacy environment challenges. For a lot of us over here, if you're working with like companies that have been around for a longer time, then you will be familiar with like some of the challenges here. Then we'll talk a bit about like data strategy. And actually this talk today was initially used as a cybersecurity type topic. For today, we also talk a bit about for Ruby how we use OmniAuth to help us enable us to overcome some of these challenges. Then lastly, we'll talk about beyond perimeter defense, which is a primary area of legacy security for the most part. Yeah, so actually the Slido question that I have over here that you can join also is basically a Q&A, like, when it comes to zero trust, what are some of the challenges that you identify most with? So 你扫了那个 QR code 过后，里面会有好几个 options 啦。At the end of the day, then we'll publish and then we'll take a look at some of the results lah. Some of the answers that you see over here are also from a survey that was conducted when this was done during an Okta webinar in Singapore as well. So we'll share some of the results there. Okay, so what do we do just to give you context on like some of the challenges that we face? We are basically a banking loyalty platform. So you can use our points for like hotels, flights booking, etc. Main thing is there's a lot of systems behind the scenes, and I think this diagram describes what we do very well. So we are tightly coupled to the different banking systems behind the scenes to help them achieve this. 所以后台的那个 data 还有系统是最少都有10到20个不同的 applications. So mainly from a security standpoint, right? We work with a lot of different kinds of providers. So for example, the biggest ones in banking would be systems and companies like Ping Identity, Microsoft Azure AD, ForgeRock, Oracle, Okta, and so on. Many applications, but generally they pose around the same challenge for us as well. So we'll just start with a quick demo so you can see like what's going on. So this is a sample administration application that we have that's used for a lot of systems and providers out there. So firstly, if you see over here, right, what happens is that you are actually attempting a login. So give me a second. Okay, so this is like the first round of login, right? Normally when we build applications, you just handle login and that's it, right? Over here, there's a second phase that I want to show you, which is maybe not something that we always do. So I'm going to demonstrate to you like an impersonation behavior. So after I access as a banking admin, right, I can impersonate a user. So a lot of the big SaaS providers out there, like your Shopify, Squarespace, in order to do proper customer support, you cannot be building every single feature from an admin point of view, right? So usually you make use of something like impersonation. So over here, just as an admin, I'm already impersonating a user over here so that I can help he or she do whatever activities that we want to do. What you've just seen is we're actually logging in twice. So now I'll talk about like some of the challenges and what that demonstrated. Okay, so with the demo in mind, what you saw around impersonation, then we want to talk about like zero trust today. So very briefly, since we don't really have a lot of time, zero trust covers 5 main pillars. How you continuously protect your data, your users, your devices, your applications, and your network traffic. The belief is that system to system, whether from front end to back end or back end to back end, we focus on continuously verifying the customer's access, right? So in a legacy environment, this is actually quite a challenge. So why is that? For legacy, we tend to focus on like perimeter, right? This graph over here, attributed to Bobix, is just a sample demonstration of all the way from your infrastructure to your supply chain, which are your external suppliers, and what are the different ways in which you can exploit your systems, right? So your adversary only just needs one entry point, but of course for you need to cover all bases as app developers. So this is a sample redacted version of the systems architecture that you tend to see. For this, I focus a little bit on like retail banking. So this is not representative of any specific bank in particular, but it gives you a sense of what are the systems that are generally involved. So at the bottom layer, you have your servers, your data, and any other services that you are using to manage the application stack. So it can be mainframe deployed, it can be making use of documents. So this would explain further up in the layer, you have your file-based data, your warehouse, your streams, your DBMS, and so on, right? Main thing is, as you start to go further upstream to your core banking services, then you have systems like customer profiles, customer cards, customer reporting, which is very important for the financial industry, customer transactions, products, deposits, and so on, right? Then on top of that, what we see as our consumer-facing app experience, then you have your internal and external orchestration services. So this can be APIs, files, apps, sitting over, let's say like a service mesh or gateway. And usually to manage identity, then you work with third-party services like your Ping Identity or ForgeRock, right? The challenge for legacy environments is some of this can be quite old, and usually there's multiple of these services, which makes it very difficult to enforce like strict access protocols, right? So I think previous talk we talked about CSR and SSR and about authentication between services, right? So you need to apply the same logic over here as well, right? But with the older services, then it's much more difficult. So from a business standpoint, what are the key challenges? So I'll just touch this very briefly. So this survey in 2017 on where your IT investments tend to go to, whether is it the front office, just a customer-facing services, or is it your back-end services? So that will be like your back office, like reconciliation, transaction processing. So usually you can see over here, survey-wise, in terms of where the investments happen, this is usually more on the front office. Your back office and middle office, a bit less focus on that. So today is 2023, right? What changed, right? So same survey that was done just like 1 or 2 years back. So this is another survey on like Asia Pac banks. So again, same thing, you notice that modernizing like your tech stack is still a core focus. So after so many years, like this is still a challenge that a lot of services face. So this diagram was picked up from an event like around 1 or 2 years ago. It shows you all the individual components in a mortgage processing system within a bank. So every box that you see over here is an application or function, as well as services that are used within the banking mortgage system, right? The lines represent like individual interfacing, like data calls and transfers that's being made. So this is really, really huge. So this is usually what you see in older systems. Today, as we develop them, we want to keep things simple, so it's not so crazy. But this gives you an idea of just within one system how complicated it can be. So how do we modernize? So first thing that we start with is always with the data. So one of the big challenges that we face is that there are a lot of like data sources, and data is split across multiple services. So for example, if I just want to authenticate a user, it doesn't necessarily mean that the same data that you use to authenticate a user and then the next data that you use to, let's say, send an SMS to validate that it is the correct access, that might not be from the same source. So let's assume that the starting point is like a single password-based login, right? So for us, we always evaluate where do we start. Who has the latest info, i.e. like which data source has the latest info, and then later on, then you can start thinking about like what are the key controls. So for us, one of the challenges that happens a bit more often is, we want to introduce MFA. Today, we expect this as basic for consumer applications. But to do this for banks that were around for a longer time, this is quite the challenge. So before we even introduce MFA, right, we actually need to find like where is that single source of truth. So usually we get this data from like customer profile, like at least when you want to do the login, right? But when I talk about, I want to do an MFA, I want to collect like let's say a phone number, that customer profile may not have the most up-to-date version of that data point in that system. So we need to pull it from like somewhere else. Sometimes it can be from a separate service by their mobile apps, backend services. Other times, similar data can come from, let's say, like reporting, because it aggregates it from multiple sources. But if you can solve that problem for them, right, which is to help them aggregate all the information, then you can start to bring in some really interesting capabilities. So one of more modern aspects is logging with like FIDO. So this is where, with your Apple and Google today on your device, you can actually, let's say, make a purchase at like Starbucks, right? And then you sign on automatically, right? So for this, you can do it with them once we can start to introduce this once you're able to merge that data, right? Especially once you get the device fingerprint from the customer. Okay, so the next bit is how do we add value back in the ecosystem by solving this problem for them, right? So one of the questions, this is one of the questions that I want to put in your minds, which is later on we'll see like how through our implementations using Ruby OmniAuth as a service layer, how we help with this process. Okay, so back to this diagram just now we showed like as a bonus, right? If I can actually help them orchestrate the different data points from the customer profile and from like the other services, then I can start to introduce other security layers such as a security Q&A on top of MFA. If I have device information even better, then we can do something that's more FIDO oriented. Okay, so next bit, for most legacy systems, we assume strong perimeter defense. But today you have the data across different sources as you have just seen, right? So even if I have strong perimeter defense for each of those individual services, if I'm being compromised over there on just one of the systems, then it doesn't really help. So when we work with these banks or fintechs, one of the key questions that we actually have to provide to them is how do I give you a secure layer sitting on top of them? Right. So what we're really looking for is like a trusted proxy, basically. So the goal is to go from like untrusted to trusted, because in legacy services we focus on like a very strong perimeter defense. Usually this is like firewall or VPN. Some banks might even say, okay, we have that and we only want to connect to you over, let's say, a landline, right? But for today's zero trust, for like continuous verification, there's not enough. So what you really want to go from like untrusted to the trusted plane is to pretty much perform like the role of like a trusted proxy for them. In this case, really, we are building like a micro segmentation layer, right, when we work with them. That means before we are authorized to make those calls to the micro perimeter below, but above that, for the customer-facing applications right at the top, in between then you have a policy and a data plane that actually works with the aggregated customer information, and you continuously verify their access. So when it comes to us performing the role of like a trusted proxy, there are many areas in which we have to focus on. So before applications even talk to you, right, we actually go through an access control policy layer. And this is backed by a fraud engine, which then allows you to continuously validate whether the customer session is valid or not, right? So if you are purchasing a coffee right now below, and then suddenly I see like 5 minutes later, suddenly your location has changed to maybe like Kaohsiung, then we know that's like impossible. So this is backed by the fraud engine behind the scenes, right? And that fraud engine then feeds on data from the data plane, right? So we have our ETL layer that actually works with the underlying services. And naturally, we also perform a few series of functions to actually protect and manage the data. So this includes encryption of your data, your masking of data on an as-needed basis. This, we find that it's actually one of those services that we actually perform for our customers quite often, because when you have access to data, it's usually raw set, right? But then when it comes to zero trust, we want to make sure that each service has the minimum set of data possible. So we actually help them to do that masking action as well. In some cases, tokenization, right? For tokenization, this one you can imagine it's more on, let's say, like credit card data. So these are the 4 key processes that we have. Okay. Now I think there's not really much time left, so I'm just going to skim through this. So data-wise, there's movement protection, there's classification and redaction that I just talked about using tokenization and masking. There's role-based access control, and there's tokenization. Role-based access control, I'm just going to use this example, very, very simple. We use JWTs, or you can use the encrypted version, which is your JWEs. This is the basis for communication of access across services internally. Key thing over here is everything is scope-based. So it can be by product, it can be by service access. Then as your systems talk to each other, then you validate this on the fly. But what is not shown over here, and you can imagine, is in order to do this effectively, then behind the scenes in your identity layer, then every service needs to be able to talk to it to do that verification on the fly. Okay, so essentially with that and your access control, then our identity services that is acting as a trusted proxy is almost like a form of like a DMZ between like our consumer-facing services and the legacy environment below. Okay, so where we use OmniAuth over here. So for us, this is almost a little bit of like our secret sauce, because OmniAuth helps us to simplify the aggregation of like identity services. So if you're a frequent user of like Ruby OmniAuth, then you'll find that every time you want to integrate like multiple identity providers, then you use OmniAuth over here. Here I just want to show you like some slightly different ways in which we use it, which are maybe areas that you don't really see. So there's access leveling, and there is account mimicry. So just now we showed impersonation, right? So we'll see soon how this looks like. So briefly for OmniAuth, there's always like the request phase and the callback phase. The code that I'll show you will focus on the callback phase because that is the verification layer. Okay, so for most of us over here, if you already use OmniAuth, then you find this familiar. So you have your middleware that is being specified or configured at your application layer. As you'll see this for Rails, you'll see this for Hanami as well. So each provider in OmniAuth is basically a different identity provider that you can actually integrate for. So I have over here in the first line Google OAuth, which you will see is quite common. Then you can write your own custom authentication service to be embedded into the OmniAuth middleware as your own provider. So this is what we do for our various banks. Remember in the demo I showed you how we logged in as an agent, and after that how I impersonated, right? So for example, for that bank A, then I have a bank A provider for the standard customer login. I've got another provider for the agent login. And I also have administrator impersonation, which you'll see soon. Yeah, so I think quick diagram on the right-hand side shows you basically how OmniAuth acts as a builder that you can register. Okay, so just now in the demo we had impersonation, right? So essentially what you saw just now when I first logged in as an agent and then an impersonate was actually a mixture of two different providers. First one was the agent provider, where I validated that the agent login was actually valid. Then after that I impersonated, right? So key thing is in the code over here, right? You have this line that actually extracts out the token representing the current administrator, right? And then using that, I set the administrator ID before I merge in the user that I was trying to impersonate. So while this code requires like a lot of like underlying service interaction, but you can imagine this is how we orchestrate how we orchestrate the impersonation of a customer, right? By merging the administrator info with the raw user information. Key thing in the session for most impersonation is knowing like which is the administrator. So over here, we actually set the administrator ID. This is important later on because if you're impersonating user, right, I also want to have very active controls on what a bank agent can do on behalf of a customer, right? So for example, I don't want the bank agent to straight away be able to change the customer's login email. So that requires some sort of access control. So this is also the policy plane in which, as you are assigning the admin ID, is also where you can assign your access control issue to the administrator when they log in on behalf of the user. Next version is the Magic Link. So I think most of us here probably have used Slack before. So Slack allows you to log in with Magic Link, right? So we do the same as well. So over here, again, it's token based and we do a Magic Link validation. So just like I showed you for impersonation, I made use of two different identity providers, right? For Magic Link, for us, you can do the same as well. If let's say you're applying this for multi-factor authentication. So with the bank's identity provider, we first log in using the bank's identity provider to create like a first session. Right now it's currently covered, but with Magic Link, I can actually upgrade the session. Earlier on, we posed the question, how do we fix like the data plane problem, right, for most of our customers? I'm going to use this example over here. So this is a sample like mobile SSO implementation of helping the user log in our services using their bank's SSO. Key thing over here is, as part of this process, right, we also have access. So this one, of course, you need to work with the clients, but if you're working with them on like mobile SSO, then you can get like basically the mobile information that your user used to log in. So in this case, let's say for example, the phone number, right? Now, once I have the information, that allows me to actually resync. So it's a bit hidden, but it allows me to resync back to the bank's identity provider services, like the mobile information. So this is represented in this line where we do a check for whether the phone information exists alongside their bank's customer information file ID. So this is us acting as a proxy over here and helping them to actually solve that data sitting in like different places problem for them. Okay, so I think this sort of wraps up like the different approaches and the ways in which we use OmniAuth. Key thing that you probably noticed is that we practice a lot of like dynamic access control. This is one of the fundamental building blocks to zero trust, which is you want to be able to restrict or limit access on the fly based on the user's traffic profiles as they come in. So this is an example of some of the practices that we and processes that we implement in the trusted proxy layer that we have underneath the hood. So you can check out, we make use of OpenID Connect, which is standard for managing access control. Then with that, right, we have multiple services underneath the hood, right? So that requires you to actually identify, does your access allow you access to ABC services, right? So that's where the credentials, together with the target audience, the audience refers to the service that you can talk to. So for that, we have an underlying service registry as well. Only then you work with the authorization server to generate the customer authorization token that gives you access to those underlying services. So if you don't have if your token does not expose the scope registered in your service registry for like cards, then your access, for example, should not allow you to then access like your cards information. Same process and framework basically applies both for your customer access authorization as well as your systems access. Okay, so this is a very simplified example of Microsoft Azure's continuous access evaluation. I think they represent the dynamic access control approach better than I can in that previous document. But you can also see over here, they have the client, they have the provider, and then over here covered is actually the policy engine. Okay, so critical change scenarios we always take note of when continuously verifying customer access, account deletions, whether MFA is enabled or not. This one seems a bit like under the hood of fuzzy, but actually this is one of the critical aspects that we always look out for when we do our policy validations. Why is that? It's because usually with past MFA, you can do sensitive actions for the customer. So actually this is where we want to put even more focus on, because if any agent or someone actually has MFA enabled, then that allows them to do things like add on additional phone numbers, add on additional emails, or even change your password, in fact, right? Then that is when an attacker can start to take over. So this one is actually quite critical for us. For us also, why it's a critical indicator is in fact some of our most serious attacks or cases that we face is not really attacking the system itself, but account takeovers for individual customers. So this is one of the common entry points, or rather one of the common signals for this particular entry point. User risk detection, just like I talked about location, that one is one big one, but these days usually you need to map that to actions like spending patterns. What do they usually buy? How much do they usually spend? Then I've got password change, similar to the MFA approach, but this one a bit less often because first you need to pass MFA. So it's usually we look for signals around changes to the MFA. Yeah, then admin revocations as well. This is the administrators being allowed to actively revoke accesses or let's say purchases on a leveling basis. Once you have this 5 in place, you can be very imaginative with your controls already, right? It might not be as simple as just like restricting access. My leveling over here can also be how much you spend, how often you spend, right? If I detect that your risk profile is high over here, I don't allow you to spend more than, let's say, 500 USD in purchases. So that's how we, also another way in which we actively protect the customer's accounts. Yeah, so I think in summary, hopefully you've seen for us, together with OmniAuth, how we enforce like endpoint level protection and an example of like user leveling. And also with the impersonation approach, you can see like how we also enforce structure on like a second or newer session that's being generated when it comes to agent support. Okay, yeah, I think we just ended on the dot. So thanks so much, COSCUP and Ruby Taiwan for having me here. If you have any questions, hit me up anytime. I'm happy to talk about any topics around security, ID verification, privacy, etc.